Noir contract syntax. Now, I anticipate this presentation to be very short. It'll be rather like a whirlwind tour of all the different bits and parts of syntax Noir contracts could have potentially in the future. And that is another point. In these bits of syntax are all non-final, so they are all subject to change as well. I also want to thank Mike as well, and a lot of these syntax and examples were taken from his initial Noir Aztec 3 examples document, so thank you to Mike. And if anyone does have any questions as well, since this is such a short presentation, just feel free to stop me at any time as well, because otherwise I'll be going through these rather quickly. All right, and before I get into the actual code examples themselves, I'll mention that the general philosophy behind these initial syntax concepts are to make the user experience as easy as possible, which generally means hiding much of the actual more complicated mechanisms like extracting these specific public variables, for example, out of the Aztec 3 ABI. Those are sort of hidden under the hood. And so the examples you will see will look a lot more like natural Noir code rather than having their logic obfuscated by specific Aztec 3 logic and pulling things out of the public ABI, etc. All right, with that, let us jump in. So here we start with a normal main function in Noir, accompanied with double and square helper functions, and this is normal Noir code that you would see today. If we wanted to wrap this in a contract, we'd simply introduce this new contract keyword and put the functions that we want inside of the contract inside of these curly braces. You'll also note that we removed the main function because contracts don't really have the same concept of a main function that a normal Noir program does. In that respect, all functions of a contract are considered to be callable, so there is no single entry point like we would see with normal programs. All right, but right now our contract functions don't do anything specific to contracts, so let's start introducing some more logic. One thing that contracts can do that non-contracts cannot do in Noir is that they can have these global state variables. So let's add one, and let's call it A. A will be secret and contrasted to a public global variable. And it's going to be this new UTXO of note type. What this means specifically is not incredibly important, but let's note that for now that note is sort of an interface that provides various functions, and we'll get into that later as well. But these allow them to be stored elsewhere essentially and shared as a global. Yes, heard someone raise their hand. I'm not, what's the question? Sorry.
I think it's from last day.
Yeah, I don't think anyone raised their hands, but I have a question. I just texted it here. So it was just, you mentioned we're callable. Is this callable by everything, or do we have similar to in Solidity where we have internal, public, private, external, like visibilities?
Yes, there will be visibilities, and just none of them are shown here in this earlier example. So right now, the visibilities are sort of this public, which we could say is FN, and whereas secret is sort of private. This is sort of an underexplored section, though, I'll admit. We're sort of still picking out what exactly these keywords should be for visibilities, if we need all four that Solidity has as well. But for now, we have these public and then private to distinguish it from this sort of like normal private visibility you have in programming languages, which controls what you can import from modules. To distinguish those two, we call like the private contract. We call those secret instead of private. But yes, there will be visibilities. All right, so after we add our note variable, we need to initialize it to give it a value. And we can do that by adding this new constructor construct. And to give it an initial value, we call the init function on the UTXO struct. And we initialize it with an initial note value, which we can create by giving the note an initial value, and the note also needs to know its owner. We can access this owner through this self field, which is somewhat like the implicit message variable that others may know from Solidity, whereas Solidity you can access message.sender. The same in Noir contract syntax could be accessed through self.sender. All right, so now we have our shared global and we have it initialized. Now we can actually use it. Let's change our square function into a multiply function, multiplying with our global. And this only reads the value, it does not write it. So to read it, we can call a.get, which gets the note out of the UTXO, and then .value gets the field out of that note. And then we just multiply that field value with the x value we were passed in. All right, if everyone's following so far, let's introduce how we would essentially mutate these globals. So let's create a new function, add to a, and here this is actually a secret function that we've made. And we're going to be adding this new b value we were passed in. And this breaks things out more explicitly. Now we have this a.get, which returns a note that we saw before, and then the .value, which we also saw before, returns a field. We can calculate our new value just by adding them both together, just in normal Noir code. And now we'll call this new note remove function to remove the old value of the note before we insert a new one in. So essentially, to mutate this, because it's a UTXO, we'd remove the entire old value and then we'd insert an entire new one. And going back to what I said before about all the machinery that was hidden, there is a lot of machinery that is hidden here as well, most notably getting this b parameter out of the public inputs and just keeping track of all these calls essentially. It may be in the future that we will have a more general API that allows us to work with more than just Aztec 3, but for now, this will be sort of adapted specifically for Aztec 3, and so this all will be rather easy to use rather than focusing on flexibility. All right, in case no one saw that, what we did was we changed the UTXO to a UTXOSet, and so now our secret A value will be distributed amongst several tree nodes, essentially. So now, let's introduce another one. If we wanted to subtract from A now, and again, A is not a UTXO anymore, it's this UTXOSet, and because it's distributed among many nodes, we need to introduce some sort of method to collect these nodes, essentially, and sum up their values. One way to do that is if we want to request two of them, we need to define a function which takes sort of all of the notes and then reduces them to a concrete number, in this case 2. In this case, we have this local reduce function, which is a new unconstrained function. This is different from normal Noir functions, being that it does not introduce constraints, which is what lets it do this non-deterministic logic of looping through potentially any amount of notes and returning a concrete amount of them. We can pass this function directly into this a.get call, which will return us our array of 2 notes. And we need to make sure to constrain these notes that are returned. So we ensure that their owner is essentially ourselves. And you'll note that we don't check the owner field of the notes directly. We do it sort of indirectly through this owner_or function. And that's because if these notes don't exist, for example, if for whatever reason there was only 1 note in the tree instead of 2 or more, if these notes don't exist, we'll have what are called dummy notes. So they're not there, but we need to return an array of 2 notes anyway. So the rest of the array will get filled with these dummy notes. And in the case of the dummy notes, this owner or function will return the parameter that it is given instead of the actual owner field. All right, after we've constrained then all the owners of the notes, we can go and we can get the value out of the notes, again, accounting for the possibility of them being dummies. If they're dummies, we return 0, we get 0 for the value. Otherwise, it gives us the actual value. And then our new note value is just going to be the sum of these distributed notes, and then minus the value that we actually wanted to subtract from our total, which is b. And then finally, we can insert this new value into our global A. Now we're going to be working with a little bit larger code next. So what I've done is I've gone ahead and refactored this code into 3 different functions. So if I go back right now and then forward again, you will see that our actual subtract from A function is much smaller. And I've promoted the reduce helper function into a full-fledged free function. Finally, I've broken out this constrain notes logic into its own function. So now for constrain notes, we have a function which can take in any amount of notes, is generic over this number, loops through all of them, constrains all of their owners, and then via the map function, returns a new array holding all the values of each note. And then looking back up to the subtract from A function, we can see how we use these functions, calling get with the reduce function, getting the values via self.constrain notes, and now note values is an array. So to get the sum of the array, we call .sum, subtract it from B, and insert our new value. So far we have introduced these global values. We have introduced these basic UTXO, UTXOSet structs. And now we'll introduce a third type of this mapping construct. And if anyone is confused about what these UTXO, UTXOsets, or even really what these mappings are, it isn't really the focus of this presentation to discuss them in detail, but rather discuss how they will be used, essentially. So as long as you understand the syntax, you should be good. All right, now for these map constructs, when we want to initialize it, we can access it with these square braces syntax to get a value out of this map. Here, for our self.sender as the key, we're initializing the value for that key to be the initial supply field that we were passed in. And again, we have this self variable, which is sort of like the implicit message variable in Solidity, which we can use to access the message sender. Now, if we want to make a transfer function and we want to transfer some amounts to a given user, here the user type is just a type alias over another field, which is just going to be an address for a user. We can access the relevant value of the map using this square brace syntax again of self.sender to get our current balance. And again, this gives us our UTXOSet from before. And if we remember from before, if we want to get a certain number of nodes, we call the .get method with the amount of nodes we want, and our reduce function to filter through these nodes. Here, I'm just reusing the same reduce function as before. Then we're using the same constrain notes function as before, and we're summing up the values to get the sum of the 2 notes that we requested. Finally, if we're transferring money, we should make sure that we actually have that amount in our balance. So we're making sure that we have enough money to pay the given user by introducing this constraint here. With that done, we can create our new balance by subtracting the amount that we have to distribute, and then decrease our balance by that amount by inserting the new value in the map. and then increase someone else's balance by introducing their new balance into the map. And then just note for this, we're using the user we were passed in, this to variable, rather than our self.sender. So in self.sender, we'll have our decreased total, and in the to, we will have the new amount that is increased by this difference. All right, finally, here's just one more example of an unconstrained function. This isn't really correlated to any of the previous examples, but we can note that there are some sort of special functions that may be allowed within unconstrained functions that aren't allowed outside of them. For example, this getAll function, if we wanted to get all of the notes rather than just a concrete number of them. This introduces non-determinism, so that is the reason why we can't do it in a circuit, which has to be sort of bound over a concrete value. But other than that, this example is just as we've seen before. We loop over an array of notes, assert on their owners, and do some logic with the actual value of these notes. All right, so that is essentially what it would look like as a user using these, and we'll move on now to what a library developer might need or might use. So if you've come to this point, you've already gone over almost all of what you would be using day to day, and this rest of this presentation is going to be talking about this note trait, what it is, how library developers might use it, implement it, and what it might be used for, essentially. Yeah, users won't use these functions directly. If we remember our previous examples, we weren't really using any of these functions, but we were using global variables with notes in them, if that makes sense. So this is an important type, but it's not one that users would have to always implement directly. All right, so as I mentioned before, note is an interface, and it has these general functions in them, along with several more that I'm omitting just to save space in this PowerPoint. So isDummy we talked about before. If we try to do .get with some number of notes, and there aren't actually that many notes, for example, the remaining number of notes will be dummies. So we'll have to have something in the interface to actually check if these notes are dummies, along with computing the note hashes and nullifiers, etc., with some other functions. However, there's a key wrench in our plans. As of today, at least, Noir does not actually have traits. So we can't encode this directly. What we can do, however, is a workaround where we can represent this trait as a struct instead. Now, all the functions that we want to include in this interface are now fields of the struct, and each field has a function type, because they're all functions that we wanted to require. You'll note that we also had to explicitly add this self-type variable for the first parameter of each function. So our struct is also a generic one. All right, now we have this struct, and this will be defined within Noir's standard library. So users would not need to define this struct manually. Users would, however, may possibly have their own custom note type. Here we're saying that a user has their custom note type, and they're calling it an Aztec connect value note. And this struct that they've defined has a value, it has an owner, and an isDummy field, and possibly some others as well. And they want to implement, essentially, note for this new note type that they've created. How would they go about doing that? Well, they have an impl for their struct already, which has some methods on it. They have a way to construct a new note. They have a way to compute the hash, and they have a way to compute the nullifier. They're pretty much all there, and their question now is essentially, how do we signal that we implement this note interface? Well, since note is a struct, we would the first thing we would do is add this struct as a field to our Aztec connect value note at the top there. So you'll note we now have a fourth field called note, and it has that actual note struct in there containing all the functions. Since we have an extra field, we'll need to initialize that field in the new function as well. So you'll note that we manually create an instance of that note struct. IsDummy, we initialize to a lambda function with one parameter that I called this, and it just returns the this.isDummy field. Compute note hash, well, we already have that function. It's self : compute note hash. And compute nullifier, same deal there. So we just reference that method and we are good to go. And we've initialized our note. And then finally, we just initialize self with that note value. And that's how you essentially implement note for a given custom note type. I'll emphasize again that most users won't need to do this, but if the user is particularly savvy, they might have a use for doing this. We will have a standard note type in the Noir standard library. So for most users, they could just import that one and wouldn't have to go through any of these steps. All right, there's one more process to this, though, and it's actually using this note. We've created the methods and we've initialized them. We've included note in our Aztec connect value note struct, but how do we actually use it in a normal function? Here is a function that you might write in Rust, and it's using Rust's trait syntax with the n:note you see in yellow at the top. But if we remember from before, Noir does not have these actual traits, so how do we translate this to use the structs instead? Well, we add the struct essentially as another parameter, a note of n, and if we remember before, note was generic over the actual parameter type, which was the note type. So my note now is just of type n, or it was before as well, but and so n is the actual note type, whereas note of n can be thought of as the methods for note type. If you're used to C++, you could think of this as sort of passing in the vtable for the struct separately, if that makes sense. So methods now contains our struct of note methods. So to access any method in there, it's the same as accessing any other struct field. You could access the isDummy function via methods.isDummy, and it takes one parameter, which is my note. Same for compute note hash, same for compute note nullifier. I'm going to go back and forward again just to show you the transformation between these two again. So here's the first example with trait syntax. And you'll note when calling the methods, we do myNote.ComputeNoteHash, for example. And once we add the explicit struct parameter, it changes to methods.ComputeNoteHash. And then we pass in myNote there in between the parentheses rather than where the dot is. Finally, when actually using the note in the bottom, you'll notice before the only difference was this function. It took one parameter. We had balance. Oh, and we created the Aztec connect value note, a new version of that, and that's just the same struct as before. So we pass in the one balance parameter, and then we just have to manually pass in the balance.note field as well for this note value. And this has been sort of an aside because Noir does not have traits today, just to show how it is still possible, but requires perhaps a bit more manually threading through these variables. In the future, one day Noir may get traits and we may smooth this over, but for now, as an initial prototype, this is how it would be done at least. And that is contract syntax in Noir. Does anyone have any questions? Joss?
I was wondering about the choice of the keyword self on the contract functions. I mean, I usually understand self as referring to say, a method on a struct, but here it seems to refer to the transaction context.
Yes, that's correct. So originally, we had copied this message variable from Solidity entirely, whereas there's this implicit MSG parameter to sort of every contract function. We thought that might be confusing, especially since Noir is sort of adapted from Rust syntax, where Rust made this explicit into self, and we wanted to sort of do the same, or I wanted to at least do the same transition for message to, instead of have it be implicit, to make it more apparent where it's coming from, essentially. So if you think of like the entire contract as sort of like an impl on like a message, then self is like the message itself. But yeah, I don't know. That was just my decision. I just thought it was a bit more clear than having it be implicit. And we already have self as a reserved word. So I thought it worked out. But again, all of this is non-final. So if anyone finds that particularly confusing, we can always change it.
Just quickly chiming in here, I think if we get people from Viper especially, they will find it very confusing. In Viper, you have self and message being like keywords, where self is the contract itself, and yeah, message is the message context.
Yeah, that's a good point to consider. Thank you.
Wait, lastly, does that mean that so how do you reference a state variable in Viper? Like, do you do self dot?
Yeah.
So what's the point of it being global?
I think you're just using self whenever it's like storage, and then if it's don't have a self, it will either be it would just be like memory or stack. So it's just making it very clear where you're working.
Right.
Where in Solidity you don't like just by the name, or like how you reference it, might not know if it's storage or if it's stack variable or whatever it is.
So can you still do a message.sender and the message is just implicit? Both. I see. Okay, yeah, sort of makes sense. I guess one thing to also bring up is the fact that secret is being used instead of something like private. This is mainly because there's actually different, you can have a private function which is just not visible outside of the contract. Then you can have a secret function, which is a function which is executed by the private kernel circuit. So there's different notions of private. And you can have a public function, which is callable from outside of the contract. Then you can have well, we don't have a word for it, but you can have a public function, which is callable by so it's not callable by the private kernel circuit. So it operates on public state. I don't think we haven't thought about what we say for public yet, but this is the reason why you don't just see the word private.
Before we get to Joss, Tom, I saw you raising your hand earlier as well. Do you still have a question?
I was basically saying the same thing as Lasse was about Viper and the self keyword. I think it'd be very nice for the state variables to be kind of read through a similar kind of mechanism, just to separate them from kind of memory variables within a function. It avoids a bunch of issues that have kind of happened in Solidity development, where there's definitely been some bugs in kind of reasonable size projects where someone is accidentally reading from storage a stale value, where they've kind of got a similarly named kind of variable in memory. which they meant to read from, but they actually read an old variable, and that breaks the maths and causes a host of issues. But if we're using self for the transaction context, then yeah, things get a bit messy.
I do wonder if that is somewhat mitigated by us having these explicit methods on these contract variables, where to extract the actual field value out of a UTXO of a note, you have to do, I believe it was .get to get the note out, and then .value to get the actual field out of the note.
Yeah, it's a bit less of a kind of priority for that reason. It's although it's less of a worry, but it's sort of nice to have.
It's definitely something to keep in mind. I'd say preventing bugs like this that you might see as common in Solidity, for example, preventing bugs is probably the #1 priority in designing this new syntax and API. So the most we can keep that to a minimum, the better, I think. Joss?
I've got the same question that Lasse put in the chat earlier. During the transfer function, how come you didn't need to explicitly remove the note that was being spent?
Let me go back to the transfer function. So I believe the answer may be because this is a UTXO set rather than a just a UTXO, but I could be wrong on that. I might have to defer to Mike for that one because I just took this example from the document there, so I'm not exactly sure on the precise reasoning.
Yeah, I think we've gone back and forth on this, like in terms of Mike's up to date, but it may be better to explicitly do it. I think there's a few versions of this, but as Jake said at the start, this is kind of very draft syntax. The goal here is just to introduce the concepts. So if people think it's better to explicitly call remove, we're probably trying towards that.
I'd vote make it explicit because I think there's a use case for building a collection of states and being able to reuse them, and then only like destroying that state later through some other method.
It could be also that we recognize that one case is the common case of inserting new value and removing the old one. And so we provide, say, a method to do that while also keeping the methods to insert without remove and remove explicitly. But yeah, all of this is subject to change. David? Oh,
well,
sorry.
I guess along the same train of thought, like, you can insert a note without removing, right? So I'm wondering, like you don't necessarily need to be creating a nullifier every single time you're inserting a note, right? So like I'm a little confused, like what determines like I am creating a nullifier this time versus I'm not?
It's a good question. My understanding here is that if you are constraining anything, so if you're reading anything from the UTXO set, under the hood, a nullifier needs to be created anyway, because otherwise you'll leak information. So just depending on the version of this syntax, maybe in this version, it's assuming that everything that is read from UTXO set is nullified, and then you're only inserting what's back as a mental model, versus kind of the other one, which I think Joss is hinting at, where you explicitly need to do that yourself. But if we go back a few examples to when we were just adding to the balance, and we weren't actually mutating. Yeah, this one, add to A. Sorry. This one, yeah. So here, under the hood, A, I believe, still gets nullified in some versions. So it's up in the air. Is what I'm trying to say. Kev, I don't know if you have anything to add.
Yeah, speaking with Mike, I think he said all reads will create a nullifier. So as soon as you read, it nullifies. And if you basically don't want to modify the value, you just write back to storage the same value. So each read is accompanied by a write.
Could you guys go into, I know you said it would leak information otherwise, could you guys maybe expand a little bit on that? Like why do you need to nullify on only a read?
I think there's two reasons. One is when you're reading, you need to be sure that you're reading the latest value of the state. And the only way to do that is to have nullified it after every read. So let's imagine I have $1 million in a note from like very early on in the protocol's life. I could create valid Noir proofs by just kind of reproving some hash path saying that I have A and it's still worth $1 million, but the actual state of the chain would be much further along. So you need to nullify after every read to ensure that the kind of current value of A, my giant note in this case, is up to date. And I think the simplification probably came from that if you have to do it on reads, then maybe it made more sense to kind of only insert when you're writing.
To read, you need to check not nullified, and so you reveal the nullifier, I think, to the server to do that, which would leak information if you didn't actually then nullify it and recreate it. I think that's my understanding.
Yeah, that makes sense. That makes sense to me. Thank you, guys.
Santiago?
This is the meeting to ask back. How's the Noir compiler implemented? Like how much does it share any code with Rust compiler? How much is being reused versus being written from scratch?
You were going a bit quiet there. I heard you ask, does the Noir compiler share any code with the Rust compiler?
Yeah, basically.
Was that your only question, or did you have any others as well? Okay, so does the Noir compiler share any code with the Rust compiler? No. The Noir compiler is completely our open source project, and you can find it in noirlang/noir on GitHub. And yeah, we do use some Rust libraries, but we do not use any parts of the Rust compiler itself.
I guess the asterisk is that I did copy from Rust Analyzer, which is the linter, their module, the way they did their module system.
We've got some design inspiration, but we haven't used the Noir compiler itself. I've seen the code in question, though. It's yeah, it's nothing too major, and it's just part of the sort of module and name resolution system. All right. If that is all the questions, then thank you everyone for coming. I hope you got something out of this presentation. As non-final and subject to change as the syntax is, it's always nice to be able to get more eyes on it and more opinions on it, so that the whatever is chosen for the final syntax can be all that much better.
Oh, I had one other question. Just I know we've talked about this a lot with different people with Mike, but kind of UTXOs versus notes. Like in the single case where you have a UTXO that's of type or trait note, why isn't the why isn't the name of the thing that's a trait a UTXO? I guess. feels like we have an additional wrapper on something. Like what additional benefits having note and UTXO as two different words have in the language here.
All right, so your question is why we have these 2 layers, or you could say 3 layers of an onion instead of combining UTXOs and notes and combining UTXO sets and notes?
Yeah, mainly for the UTXO note case.
I think the answer is just for reusability. It could be that we could provide like a type alias for a UTXO of note. But if we're implementing notes, we only want to implement note once. And so having one like struct for a note makes sense. If we were to combine that with, and then having several different wrapper types that contain notes internally, rather than them all re-implementing the note logic, is convenient. A suggestion, note to UTXO.
Yeah,
So
kind of. That's what I was.
yeah, I believe in the initial proposal that Mike gave as well that this note was separate from a UTXO. It does not itself have the UTXO. Not sure what to call it, but the API of where there's one distributed thing and then it can be removed and then replaced with another. It's rather just an internal interface for something that provides these like hashing methods and has a nullifier, etc. So it's a bit more general than a UTXO.
Oh, I think I get it. You mean that UTXO has a method get, whereas like a note doesn't have that method. It has the interface of the note.
Yes. But yes, it may be that in the future we want to smooth over these differences, and we could definitely look into exploring other ways of organizing these, renaming existing types. Yeah, would ideally like to change it, but no good name has come up. Yeah, if anyone has any really good ideas for names that are very readable and are immediately apparent what they are, especially to someone with less experience in this field, then that would be great. Raul?
Potentially a dumb idea, again, just joined, but I think we should also think about not using the word UTXOs, etc. on the syntax, only because it's confusing to people who aren't familiar with these kinds of things. Like most of our developers will probably come from the blocks like Ethereum world, who don't know what UTXOs are and shouldn't really have to know if they're just using Noir.
Mm-hmm.
I would say that's
I'm happy to
all
think
these names are
about
talking about even note.
Yeah, I agree with David. I'm happy to like brainstorm as I onboard into these things now.
How about this then? Whenever we do revisit these names, because these aren't actually implemented in Noir yet, they're not even in the standard library. Whenever we do want to sort of think of these names, I'm going to put a note about them in the Noir Lang channel on Slack. And anyone with an opinion can sort of look at that thread and put their own comments on it of, I think this would be clearer. Perhaps we should consider this instead. Perhaps that might be a good way to get everyone's opinions in. I'll note actually as well onto my thinking of it I don't actually, so I'm very much in the case for usability for users and for new users especially. However, I'm also of the opinion that sometimes names can be too simplified as to they're trying to sound too general, too friendly, and it makes them more confusing as a result. For example, if we name it something like, I don't know, leaf, it's could be very friendly, but it also comes with like connotations that UTXOs might not have. Whereas if you go instead the other direction for this more confusing but precise name like a UTXO, there's no other existing like concepts in someone's mind that it could be confused with. You're essentially forcing them to start from scratch and like actually learn what it is. I'm not saying like this is the approach we have to take, but it's something to consider if we don't think of any other more applicable names. Savio?
I do want to quickly bring up that it might be worthy to do the discussion on discourse instead of Slack, where things might get lost. So yeah, looping in, tying into the presentation last week, we might want to use discourse to just discuss the longer term discussions that we should be having.
All right, so it looks like there's been some comments as well in the meantime. Would it be possible for someone to write a library that completely abstracts the concept of UTXO/note away from the user? Or no, it is fundamental to the way developers need to reason about quote-unquote secret state. So I suppose it depends on what you mean by completely abstracting away these concepts, because no matter how you abstract them away, you'll still have to provide methods to interact with it somehow. And even as soon as you provide like a method to like just get a value, you're already like one step closer to recreating the existing abstraction where we already sort of have this getting a value method. But that's also sort of getting into the weeds, because the real answer is that yes, we do want to explicitly allow users to do this and create their own wrappers. And that's part of the reason why I sort of went into the whole offshoot at the end about Note being a sort of interface that you can think of and provide your own values of like these functions for, because we could have just used our own concrete functions for those, but in making it an actual struct, our plan was for really to users to create their own notes, to do the things that they might specifically need to do, which allows them to create their own wrappers for these. And they could theoretically do the same for UTXO and friends as well. Yeah.
I was just going to add that it depends who you mean the user here, David. If you mean like a Noir developer or an Aztec 3 contract developer, I think yeah, kind of what Jake said, but the goal of Aztec.js is to abstract that away from app developers. So if you're kind of using a ZK ERC20 contract, you don't need to think in UTXOs. You can think in terms of like balance plus transfer, and so Aztec.js and the kernel circuit kind of achieve that goal.
Yep, got it. Thanks, guys. That makes sense.
I'll also note that an eventual goal of Noir is to be sort of agnostic to these Aztec 3 like distributed contract systems. So in the future, it might be that we get even more flexible tools to allow users to program with any similar sort of contract system. And once we get those even more flexible tools, then I would very much like to say, yes, users would be able to implement their own versions of these structs and would be even able to implement them for different chains, trees, etc. But that's just in the future. All right. Sounds like that was all the questions. So again, thank you for coming, everyone. Hope you got something out of this. I know I did. It's always good to have more discussion on language design, I think. The more minds, the better.